Let's take a look at these two waveforms. This time we are going to have two voltages and we have two sine waves, but phase shift angles have different signs. So what I have to do first, draw the XY plane. Where my y-axis is going to represent the voltage in volts. My x-axis is going to represent the angle in degrees. Anytime we talk about the sine wave or cosine wave, we're supposed to remember about very important angles like 180 degrees, 360 degrees, 90 degrees, 270 degrees. Next, look at the first equation. First equation has phase shift angle equal 20 degrees. What does it mean? It means that this waveform is going to start 20 degrees ahead of the reference point, which is 0. This is my reference point, and I'm going to start ahead 20 degrees. So my peak value of my voltage is 20 volts. I'm going to draw the dashed line in order to make the wave looking symmetrical. And this is going to be minus 20. degrees. We know that half of 90 is 45, somewhere over here, and 20 is going to be approximately somewhere over here. So this is going to be minus 20 degrees. Next, I have to move 90 degrees 20 degrees to the left. I mean, I have to move this point to 70. So I'm going to have 70 degrees. And this is going to be positive peak of my voltage. Next, 180 has to be moved also. I mean, this point has to be moved to the left by 20 degrees. So this is going to be 160. And this is my negative going 0 crossing point. 270, I'm going to move to the left also by 20, approximately. This is going to be 250 degrees. And this is going to be my negative peak. 360 is going to be moved also to the left. And this angle right now is going to be 340 degrees, and this is going to be my positive going 0 crossing. Next, I'm supposed to connect all these points together. Okay, and this is the wave which represents this equation. Next, I'm supposed to draw the second voltage. The second waveform has to start 30 degrees behind the reference. Why? Because I have negative 30 degrees. So I have to find how much is 30 degrees. 90 divided into 3 pieces is going to give me 30. Okay, so means I have to move my reference 30 degrees. So this is going to be 30 degrees. 90 I have to move also to 120. This is going to be 120 degrees. 180 plus Torre is going to give me approximately somewhere over here, is going to give me 210. 270 plus Torre is going to give me 300, and 360 plus Torre is going to give me 390 degrees. Next, please notice that V2 has peak, positive peak, means we have to start from the positive half a cycle, 4. So 20 divided into 5 pieces is going to give me 4, 8, 12, 16, 20. So this is going to be my 4 volts. 4 volts, this is going to be my voltage peak. Positive voltage peak. And I'm going to have over here negative voltage peak, negative 4 volts. I can draw my waveform, and keep in mind that this is going to be my 0. This is going to be my positive peak. At 210, I'm going to have negative going 0 crossing, and at 300, I'm going to have negative peak, and at 390, I'm going to have positive going 0 crossing. Now I'm supposed to connect all these points together. Because I have positive voltage over here, I start from positive half a cycle. Simply connect all these points together. As you can see, this waveform is lagging the reference by 30 degrees and has peak value 4 volts. Negative peak is negative 4 volts. So the final answer to this problem is that voltage V1 leads V2 by 50 degrees. Why? Because I have 20 degrees over here and 30 degrees over here. That's why I have 50 degrees together. Or V2 lags V1 by 50 degrees. And this is the solution to my problem.